chronic disease epidemic follows a predictable pattern, a biological computing architecture crashing under the weight of inputs it was never designed to process. To bridge the gap between abstract metrics and clinical reality, Dr. David Unwin developed an educational framework that replaces the standard glycemic index. This framework uses a teaspoon of sugar equivalent. Exactly 4 grams of pure carbohydrate represent 1 teaspoon. A healthy adult maintains a circulating blood glucose concentration of exactly 1 teaspoon. This 4-gram limit is tightly regulated across the body's 5-liter blood volume to maintain homeostasis. Standard starch-heavy meals introduce a high-velocity carbohydrate load that dwarfs this physiological baseline. These inputs mathematically exceed the blood volume's hard-coded processing limits. To manage this surplus, the body executes massive insulin surges to clear the glucose from the blood as quickly as possible. Systemic cellular overload begins the moment dietary inputs surpass these regulatory thresholds. While glucose is processed by cells throughout the body, fructose absorption follows a distinct and inherently pathogenic metabolic routing. Fructose absorption entirely bypasses peripheral circulation. It is funneled directly to the liver via the portal vein. Inside the hepatocytes, fructose escapes the critical regulatory checkpoint of glycolysis by bypassing the PFK1 gatekeeper enzyme. This results in an unregulated substrate flux that proceeds without any feedback inhibition. This creates a surplus of acetyl-CoA, forcing the liver into de novo lipogenesis, the rapid synthesis of saturated fatty acids. The resulting intracellular malonyl-CoA acts as a direct inhibitor of CPT1, which completely blocks the liver's ability to burn fat for energy. Because fat oxidation is blocked, the liver must accumulate these newly synthesized lipids, leading to steatosis. Standard blood panels for AST and ALT often fail to catch this damage due to extreme diagnostic latency. Clinical reference ranges for these enzymes are based on populations already compromised by metabolic syndrome, allowing early-stage fatty liver disease to go undetected. The liver essentially acts as a silent data sink, accumulating lipid deposits for years before legacy medical systems register an alarm. Persistent consumption of these metabolic substrates stems from an engineered neurochemical hijack.